What if your workout could power your life?
Our product is electric generating skipping rope.
So next we go for the basic concept. The first one is oscillatory motion. It's caused by the revolutive motion of the skipping rope. So second, they really influence the angular velocity of the ball bearing. So as the rope turns, the kinetic energy will convert into electrical energy. Next, each oscillation increases input energy towards dynamo. This means that the energy will be converted through the dynamo inside.
But in this kind of rope, we are not using the dynamo. We are using a DC motor, which is
Because the DC motor and the dynamo is actually using the same concept, which using the flux magnet and the other the rotational motion. So we just simply use the DC motor to run the electricity.
Next, rotational motion. So for the first concept, the motion of the ball bearing caused by the ropes and by the user. Angular velocity is determined by the skipping speed of the rope. So it means that the faster we skipping the rope, the electricity will be more generated. So the last one is enable conversion from mechanical energy into electrical energy. And so this conversion is via the DC motor itself. So top, it will drag the ball bearing of the skipping rope to spin and also arise from the force caused by the swinging motion. So this is the formula of the top itself. So next I will pass to Abid now.
So the first concept that I'll explain is magnetic induction. So what happens is the handle of the skipping rope contains a small dynamo, or in this context, we uses DC motor that utilizes magnetic induction. So whenever the user skips, the motion causes a rotor within the handle to spin in the presence of a magnetic field. So when you spin, there will be active cutting of the magnetic flux, which, as we learned, produces electromotive force, thus generating electrical energy. So the next concept is Lenz's law, which states that the direction of induced current will oppose the change in magnetic flux that created it. So, like I mentioned before, we have cutting of the magnetic flux. So there is Lenz's law in our product, and the direction of induced currents will oppose. So, finally, this Ohm's law in our product, if we were to expand further, we will seek ways to manage the resistance to prevent overheating.
so by having this kind of the product, you guys can see that by related the magnetic flux in the skipping rope, by we rotating it, we will create electric, which is produced and then will be shown inside the multimeter. Okay? And also as a community development, we do understand that by relating the skipping rope, we exercising, which is it also produce an electrical power. Okay.
Alright, so for the procedure, first we take this skipping rope handle, we dismantle it so that we can put the DC motor inside the skipping rope handle, and then we attach the end of the skipping rope to the tips of the DC motor so that it will be attached and will be rotate while we skipping our skipping rope. So by that we can functioning the product as Imran said that we want to add rechargeable battery and the holder, but we cannot find the suitable material in our term right now, so we change it with some wiring inside the knee so that we can connect with the voltmeter so that we can show there is elasticity running in our product.
Okay, so the function of the skipping rope, of course, to when we skip, and then the DC motor is when to generate, to convert the kinetic energy to electrical energy. And then to show that it actually really works, then we connect it to the voltmeter. And so here is our exploitation cost. However, right here we don't use the rechargeable battery because we don't find any suitable rechargeable battery to put it on the handle. And then so we change the rechargeable battery to a voltmeter so that to measure the electricity that go through the wiring from the motor to the wiring. And the total cost we expected is the 41 ringgit. and then this is the normal speed, and then gradually increase the speed. Okay, rising, and then slowly increase the speed again. Actually our plan is to use the rechargeable battery to connect from this wiring to rechargeable battery at the handle. However, the rechargeable battery size are too big for us to put it on the handle, so we plan to just use the voltmeter to show that there's electricity running.
I think what makes our product special is that the keboleh pasaran product, you know. Because of what? Because this product, even at the secondary schools, at the primary schools, you know, even at the foundation, even at the degree also, they can buy the product, you know. Why? Because it is so boring, you know. When we learn theory, we don't understand anything. We don't get it. Why? Is it really true when there's an induced current? When there's a magnetic flux, there will be an induced current. So they cannot imagine it well. But when we're having this kind of the products, you know, we prove it in front of them, and yeah, for sure, by having this kind of product, they will love to have it.
So that is an education point of view, but we can also look at it as a skipping rope. So skipping rope is currently rising nowadays because, as we know, health is being prioritized by the society. So this is not only it is a high quality skipping rope, but it also comes with the added bonus of generating electricity. So skipping rope enthusiasts would prefer this product because there is more to it.
Yeah.
So, just in the conclusion here, a skipping rope that generates electricity using DC motor, providing energy conversion can be demonstrated with the minimum components.
Yeah, because we're just using 3 components here. Is it 3 to 4 components here? Skipping rope, DC motor, multimeter for just checking. So, it's just a simple product with a minimum cost for us to demonstrate this kind of the project to the other people, especially on the magnetic flux. And the last one, yeah, this one I'm saying just now, free and easily replicable model using affordable materials, providing scope with a cost-effective alternative to conventional energy demonstration tools. So I guess that's all from us.